Hello friends, this is the first from a series of videos that I'll be doing by picking up questions from different competitive exams. This one is from Jest 2019 and let's begin. Let R be the position vector of a point on a closed contour C. What is the value of the line integral R dot dr? For this question, let's first understand what a position vector is. Let's draw a set of axes for that. Alright, and now let this be the x-axis, let this be the y-axis. Let's say we have any point here. Now this point, let's call it P, let's call the origin O. There is a line connecting O to P. Now this is a vector, okay, which directs from O to P, and this vector R is the position vector of this point P. At P, we have a certain x component, let's call it x0, and a certain y component y0. Then our R for this, R for P, will be x0 in the x direction plus y0 in the y direction. So our position vector in general will be x in the x direction plus y in the y direction. That's our position vector of a point on a closed contour C. For closed contour C, closed contour here basically means a curve, but at every point on the curve a function is defined. Okay, a function, let's say this is our curve, let's call this B. This is our x-axis, this is our y-axis, and at every point on this curve a function is defined, like f of x comma y is x squared plus y squared. Then at any point here the function will have some finite value, like f at this point, f at x0 comma y0 will be equals to x0 squared plus y0 squared. Now this is a contour, it is a curve. On every point of the curve a function is defined. Okay, now next is, what is the value of the line integral? Line integral. For line integral, we can take this curve again. Okay, what I wanted you to see is that we are given a closed contour. Okay, this is an open curve. I mean, it is open. If it has to be a closed contour, what happens is that the beginning and end points are the same. It has to be closed. Now this is closed, the earlier one was open. Okay, next let's move to line integral. We'll draw a set of axes again, and we have got the x direction with y-axis. Now as I defined that on every point in a contour, on every point in a contour B, a function is defined. Okay, now if we add up the functions f of x and y at every point, here and then here and then here and then here, then what we do is we actually integrate it throughout the line. Okay, we integrate f of x and y as we move a very small distance dr, and here we have done a dot product. We do this for forces as well, and it might be clear that way. We'll do that way later on. For now, all we need to do is the integral is the dot product of the function with an infinitesimal displacement. Okay, now that's a line integral. So now we are ready to solve the question because we are done with the preliminaries. So let's take this away from here. and begin our question. Let's take this as well. Okay, let's begin doing our question now. We are given, we are told we need to have a line integral of r dot dr. We know from earlier that the position vector r is given by x plus yy in 2 dimensions. If we are doing in 3 dimensions, we will simply add zz. Okay, but for now we'll only do 2. Because we are considering a contour on a plane rather than 3D. You can consider 3D and do it, it won't matter much for this question. And dr will be a small displacement in the x direction plus a small displacement in the y direction. If you are doing 3 dimensions, it comes dz in the z direction, but we won't consider that for now. What we have got next is we will do this integration. Okay, but okay, first integration on the contour C, because we have contour C, and this is our position vector to any point on the contour. Then we have got here r dot dr, which is equals to integration on the curve x in the x direction plus y in the y direction, dotted with a small dx and a small dy. Now this gives us integration on the closed contour x dx plus y dy. Now you see we have got 2 variables here, first dx and then y. So we need to know the limits of integration for both x and y. Okay, and from this image what we can see is, from this diagram, is that the curve, wherever you take the beginning to be, let's take it here, then it ends here, which means the initial points of x, if x began here, then it has to come a circle and end here. Similarly for the y. So what we can do is we can separate this into 2 integrals. We have x dx from xi to xf plus integration of y. Now this is x squared by 2 xi to xf plus y squared by 2 yi to yf. This is xf square minus xi square plus yf square minus yi square divided by 2. But what we know is that xf equals to xi and yf equals to yy, so this is 0.